Well, good afternoon, everybody, and thank you very much for inviting us to speak at this conference today. I'll just introduce myself. Oh, one or two more coming. Yeah, for those of you who don't know me, I'm Steve Mills from P&B. I'm the fancy title as a Group Technology Brand Manager, and I've been asked to talk to you about sum up the entirety of agricultural technology in half an hour, so that'll be easily achieved then. So what we're going to look at this afternoon, go through a quick agenda. We'll have a look at the background of P&B and technology. We've actually been at it quite a long time. We'll have a look at where we started and where we've come from. We'll have a look at some of our RTK solutions that we can offer to farmers at the moment, and then we'll look a bit broader into some of the more advanced technology bits and pieces. Guidance now pretty much is almost old hat. Technology is very much different to guidance these days. So we'll look at the telemetry, we'll look at the task data, some of the challenges we have to face in making that all work together. We'll look at Isobus and variable rate control, AgriRouter, and then what P&B are doing going forward with technology. So it's a huge topic, so we'll crack on. So, a bit of background with P&B then. I mean, we were an early adopter of guidance, largely with the tractors from Challenger brand. Bigger the tractors, bigger machines, the more guidance made sense in those days. So we were a very early adopter of guidance. And because the factory didn't really have a solution, we sort of partnered with Leica to give us a very cost-effective and a very reliable N-trip solution on that, which worked well for a lot of years. And it helped us build a network of 9 of our own RTK base stations. Now, they went live in about 2008, 2009, and we've been running very successfully on those ever since. And it established us with our customers as not just a supplier of equipment, but also a supplier of signals as well. So the next generation of that then, those base stations now are getting very elderly, getting very creaky, and as you know with technology, anything becomes difficult to back up and support when it gets old. So what we've done, we installed a brand new network of base stations last year. We've got 8 brand new base stations. There's one of the antennas going up at one of the customer's premises. And we've also invested in some top quality software and hosting solutions. So we're actually one of the industry's best hosters for N-trip solutions. It gives us a nearest base solution. So wherever you're working within our area, your tractor hops onto the nearest base station, so we've always got reliable signal close to. We've also got roaming SIM cards now. Because we use the N-trip solution rather than wireless, your data comes across the internet. It's very important you have a robust and reliable connection. And as we all know with our phones, sometimes that's difficult to guarantee with a single network provider. The SIM cards hop between networks to give you the best. It's a secure system, one username, one signal. It's reliable and it's universal. That's the beauty for us. It enables us to supply signals to stuff that isn't just our own. I've currently supplying signals to Agrifax sprayers, Amazon Pantera sprayers, and we can do anything that can accept an N-trip signal. That's where our bases are located currently. So we've got 8 of them covering wide area, and if you're anywhere between up to 30 or so miles away from one of those bases, we can supply you a signal. And we've got an 8th base there that's about to go live, hopefully in the next few weeks. We'll get that on the network as well to fill in that gap across at Holderness. So, leaving guidance then, like I said, that is almost now considered to be old hat, because guidance is pretty much a standard kit out the factory now. So we're looking more now at what we can do with data from the machine. It's either sending data to the machine or receiving data from the machine. But we need to be a bit clear on what we're talking about. So really there are currently 2 different data streams that we're dealing with. The first one we group under telemetry, and that is very much about the tractor or the combine or the sprayer. So it's the machine itself, and it's where are they? So where are they located? What are they actually doing? Are they in work? Are they idling? What job are they doing? And the key channels from the CAN bus of the tractor. In other words, the tractor's main parameters that its brain is using to do with its engine, its transmission, its hydraulics, and how it's working. That also, you have access with your dealer, has access to that, so we can look at machine health, and we can look at does it need service, is there a fault, and sometimes the machine can let us know we've got a fault before the driver's aware. We've also got task data. Now this is a different side of it. This is not to do so much with the tractor itself as the work the tractor is doing. So this, we use the term task. It's a catch-all term that's any job you can do with a tractor really. And you send a task to a tractor. It might be go and cut that hedge, it might be go and harvest that field, it might be go and drill that field. But it's how you send the information and the job you want the tractor to do to the operator, to the tractor. Now, good old-fashioned ways, you'd have gone and told him, get on that, and go and plough that field over there. And nowadays we've got more and more people working at great distances. It's not often as easy to do that. The other thing is you want to get data back from what's been done because you want that for your own costings or proof you've done it. So you actually need to get it back. So if you've been sent a spray recommendation from your agronomist, you may want to receive that as applied map back, so you can then send it back to your agronomist and other regulatory bodies and say, well, that's what I was told to do and that's what I actually did. Looking at the telemetry then in more detail, so this is the machine itself. Now AGCO have a system, we'll look at AGCO first. AGCO have a system called AGCO Connect, and it's across all the brands, and it gives you a fleet overview, so you know where your machines are, the status, what they're doing, and it's real time, so you can actually look at your phone, look at your laptop and see where your machine is now and what it's actually doing at the moment. It's available as an app or as web-based applications. You can use it in the office, you can use it on your phone. And it uses a thing called the AGCO connectivity module, which is that black box that doesn't work on the telly, the pointer. The black box in the middle sits on the roof of the tractor and actually communicates via the internet between the server and therefore the app and the machine. It can currently be fitted to all AGCO tractors, Fendt, MFL Valtra, Rogator sprayer, and also it's now standard on the Ideal combines. It's available right across the brands. As you can see, we've included Challenger on there because although it's disappeared from Western Europe, it's still very much an AGCO brand in North America and Eastern Europe, and all of those brands have their own face of the app, or you can have the one on the top right, which is AGCO's generic one if you've got a mixed fleet. So what you would see if you've got that on your phone is the list of your machines. You can then dig down into those machines and see, say, where they are, what they're doing at the moment, what the current work practices are. You can also scroll back in time. So if you want to know what it did a week last Tuesday, you can look back and see when that is by the date. You can also see the map as to where your machines are actually located, so you know where they're actually going. Now, we are very much seen as an AGCO dealer, but JCB is a hugely important part of our business as well, and JCB are well in front of the curve with telemetry, been doing it a long, long time, largely driven by the plant industry. And you'll see a lot of these slides, the pictures on there are diggers, but it does refer to load-alls and fast tracks as well. The telemetry side, farmers, it's been great, isn't it? Most of your machines are based very locally and most come home at night. So you don't actually need to know what that machine's used in terms of fuel because it's come home. You know how many hours it's done. You know if it's got any problems because you've spoken to the driver. Plant hire firms tend to have stuff spread all over the place. Truck guys, they tend to have machines all over Europe. They want to know where they are, what they're doing. So the telemetry's been led by them. So JCB call their system LiveLink, and you can see it's been going for a long time. It's available in 186 countries. It's nearly 1,000 dealer accounts. Every new JCB comes with a 5-year contract for LiveLink as part of the standard equipment. And there's over 250,000 connected machines. It's a massive, massive data pool they've got. It's a very, very good portal you can use to look at your machines there. So you've got GPS location, you know where everything is. Again, the health alerts. You can send them as an email, as a text message. You can see if you've got a problem with your machine, where it is. And the other thing is with these is the in-depth analysis of the fuel use and the working time. So you can see very much what you're getting out of each machine and how the operators are behaving. Because if you've got lots of machines, you've got lots of operators, some will be better than others, some may need educating, some may need replacing. So it lets you look at what they're doing and where they are. The other thing is, very important to plant, but becoming more important to agriculture as well, is these machines are big expensive lumps of kit and they're very easy to pinch. So you can actually set up what we call a geofence. So if you've got a farm and your farm's in the middle of that yellow block and you've said, notify me if any of my machines go outside of that area, you'll get a text message or an alert to tell you that your load-all has now disappeared across that barrier and it's heading for the A1 and it's heading north where it's going. The other thing with these, you can set curfew hours and alerts. So again, you can say, notify me, there should be nobody on that load-all after 9 o'clock at night or before 6 in the morning. So it starts up outside those hours, notify me. So you know if it fires up at 1:30 in the morning, unless you've given someone instructions to take it, it's probably going to the nearest cash point to make a withdrawal. So you can set up an alarm to where it is. It also allows you to monitor your fuel usage, so you can see what these machines are using and where, so which part of the operation they're using the most fuel. And you can also look at their idle time utilisation and monitoring. So it's good to know with some of these things, especially things like load-alls. Be sat for hours left idling while you're doing other stuff. Now, it's all very well and good, may not use a huge amount of fuel, but if you've had a machine with a 3,000 hour warranty contract and you leave that idling for just 10% of its time, that's 300 hours of your warranty and half a service that you've wasted just sitting there ticking over. And if it's more than that, you really need to be looking at how you're utilising your machines. So there's a lot we can gain in here, and as margins get squeezed, we need to be looking at every marginal gain we can get. We can also look at the engine performance and drive modes, so maybe not so applicable to low-doors, but certainly if you've got a fast track in the field, seeing how it's performing, what it's using and how it's being driven is all good information when you're looking at how these machines cost and how it all tots up. The machine notifications and tracking, again, as you can see, there's a quarry with many, many machines working, but you can see where each one is. Now, in an industry like agriculture, we can have members of staff working at opposite corners of the farm on their own for long periods of time. So it's often no bad thing from a health and safety point of view to be able to say, well, he should have been back by now, where is he? And he's been sat there for some time. Has he got a problem? Do I need to ring him and see he's okay? Do I need to get in the truck and actually go and make sure he's not trapped under the machine? So seeing where people are and what they're doing, it's not Big Brother is watching you, it's often very good from that perspective as well. As you'd expect, it's also available on a mobile app, so you can take it with you in your pocket, because being at your desktop's all very good, but 9 times out of 10 we're out and about. And there's also a thing called LiveLink Lite. Now this is a simpler telematics system, which is good for machines that aren't necessarily suited to the full integrated system. So if you've got a big excavator, a loader, or a fast track, it's very easy to have the full telemetry. If you've got a little genset or a little hydraulic breaker unit or a mini digger, it may not be so applicable, but you want to know if someone's using it out of hours, if they've taken it out of the area they're meant to be using it in, and also knowing if it needs a service or not. Again, if you've got 100 of these machines dotted all over the countryside, you can't physically go and check the hours, but if you know one's due a service in 50 hours, you know that one doesn't want hiring out next week, it wants going in the workshop. So that's the telemetry side, and now we're looking at more the task data. So that's about the tractor and where it is and what it's doing. This is about the work it's doing. Now at some point in the future, you'd expect these two data streams to go into one, and hopefully we'll be able to use that from one source and one thing, but that's still a way away. So at the moment, we have to use this task data for the jobs we're looking at doing. Now, there are significant challenges with task data, and these are often not used or generated in one system or service provider, and they can be difficult to move between machines and between systems. So, if you've got machines of different ages, that can be a problem. I've just had that recently. We sold a guy a brand new tractor, and he wants to plug his old fertiliser spreader into it, and they won't talk because the tractor wants an ISOBUS system, bang up to date, and the old fertiliser spreader is still on the old serial rate command. So we've had to put an old screen in that tractor to enable it to talk because of the different ages. We can have different data formats, shape files, the JSON files, ISO-XML, KML, and other proprietary files that belong to actual, be they Trimble, be they Hexagon Agriculture, be they Topcon. They're specific to those guys. No one else can read them, no one else can handle them. It all gives us problems when we're trying to make stuff work together. And I say, the interoperability between manufacturers, what's the incentive? Because if I make a tractor, and I make a drill, and I make a combine, and I make a sprayer, I want you to buy them all from me. I don't want you to be able to use it with his sprayer and his drill and her computer system. I want you to get it all from me. I want to keep hold of you. So there's been historically little incentive between manufacturers to make stuff work together. And the result is it's very frustrating for you guys, the users, because you might have an agronomist who's using money boots, but he can't send you stuff into Gatekeeper because they won't talk, and then you can't send stuff out of Gatekeeper to your tractor because they won't talk, and then you can't get stuff back to go into your farmer assurance scheme because that doesn't talk. So what you're gathering with this data, what you can actually do with it is very limited because you can't handle it. Now part of that is because we have some very complicated data flow. So poor old farmer in the middle there, not often you hear an agricultural dealer say poor old farmer, but the poor old farmer's in the middle there, and he's looking at lots of different sources of data. So he might be looking at drone technology, he might be looking at something from satellite imagery, he might be looking at soil sampling results, and other observations and measurements that he's then feeding into his advisor with his crop plan and with the history of what those fields have done. The advisor is then looking at all that evidence, and in light of that makes a recommendation. That goes back to your farmer. The farmer then has to create a task. He then sends that to his operator's machine. The operator of the machine goes and completes the task. That data is fed back to the farmer. That may then have to go back to the advisor to say, yeah, that's what you said do, that's what I've done. That can then come back to the farmer, and then it goes out as reports to partners. So it may be a contract farming agreement, it may be other partners in that farm, it may be some sort of inspection